Chapter 3 is all about interpreting context of your correlation or whatever graph you have. So your response variable is basically the outcome, which is the dependent variable, and an explanatory variable is what predicts changes of the outcome. So if I say car weight helps explain accident deaths, car weight would be the explanatory variable which predicts the accident of deaths, and the explanatory variable would be the x value that occurs the y value. When you're describing the relationship and the overall pattern, you want to remember the direction, form, strength, and outlier. So you're going to explain and interpret these features. So if it's a positive or negative association, or the form is linear, non-linear, or is it clustered, the strength would be weak or strong, and the outlier would be an individual value that falls outside of the overall pattern. So in context, when you're explaining your outlier, you want to describe in context. This is your regression line, and if there's a high x value with a low y value, that will be your outlier, while the other individuals are around the regression line. Correlation is just the direction of a linear relationship. R is always a number between -1 and 1. If there's any number beyond or far from that, it is not a correlation. It indicates a linear relationship, and if R is bigger than 0, it's a positive association, and if it's smaller than 0, it's a negative association. If it's near 0, it's a weak linear relationship. To figure out the strength, you just need to remember these few factors. So if it's between 0.1, it's very weak. If it's between 0.1 to 0.3, it's moderately weak. 0.3 to 0.5 is fairly strong. 0.5 to 0.7 is fairly strong. 0.7 to 0.9 is moderately strong. And 0.9 to -1 to 1 is very strong. And that applies to both sides. So remember that. And that would be your regression line. The predicted y hat equals to a, which is your y-intercept, and b plus bx, which is your slope. So when you're explaining about your y, it's a predicted value of y when x equals 0. For b, it's the amount by which y is predicted to change when x increases by 1 unit. So when it says 1 unit, you're going to put the unit that is in your problem. To find the slope, to find the regression line, you want to use these equations. So you're going to plug in this number and this number to predict your regression line. To find your residual, it's your observed y minus your predicted y. To find those in your calculators, you just need to remember these few factors. Just write them down, or remember, get used to using the calculator. For residual plot, that will be your way to find it in your calculator. This chapter is all about memorizing how to interpret your data with context. So if your residual plot shows no obvious pattern and points are randomly scattered, the linear model fits the data well. If there's an obvious pattern, it means that the linear model does not fit the data well. So your standard deviation of residuals, which would be S, is basically your residual, the sum of your residuals squared over numbers minus 2. You don't have to remember this, and this is just the form for your calculator problem. And what you need to remember is this. Using the regression model, the computed predicted value of y will be off by S. To interpret it R squared, it will be, there's about this amount of number of variation in value of y that counted for by the regression line of y on x. You would just change the context, whatever's in the context for this case. Remember that R is coefficient of correlation, R squared is coefficient of determination. And if you have these informations, you need to say we say instead of conclude. X is a good or bad predictor of y. And remember, find B and A like this. Just remember. For computer regression outputs, you just need to remember that constant means A, and whatever over here would equal B. And then there will be your standard deviation of residuals and your R squared. With those information, you can find your regression line, which would be A plus BX, and the rest you can just interpret the information. What's important in chapter 3 is just remembering how to interpret S, R squared, R, A, and B, and how to predict a point with your own data using your regression line. And that's it.